Next on our agenda is Kris Teague from the Western States. Kris is going to tell us about the testing of snowplow lighting configurations that they have been working on.
Good morning, everybody. So I'm here for WSHEMA, and we started off, this started off pretty simple, and WSHEMA put out a survey back in 2017, a year ago, and they just asked everybody within WSHEMA, how are your plow lights doing and what kind of plow lights are you using? This is from Washington. Washington used the truck light. It's a halogen light. They gave it the scoring on this is a 1 to 5 rating. I call it the Amazon 5-star rating. They gave it a 2-star rating. But they also said, within the bottom of this, they talked about they're going to move to the Helicombi light. So Nevada used the Helicombi light. Nevada gave this light a 5-star rating, and they've been using it for about 4 to 5 years. Idaho used an arrow light. This is also a halogen lamp. Idaho, they're pretty unique in a lot of the things they do. Idaho actually replaced this light, this lamp itself, with a Napa, replaceable Napa light. So, and the reason for that with Idaho, they said it gave them a little more lens temperature. But anyway, Idaho gave the arrow light a 5-star rating also. Utah also uses the arrow lamp, and Utah again, 5-star rating. Colorado goes back to the truck light. This happens to be the lamp that California uses also, and they gave it a 3-star rating. Oregon DOT uses the truck light also. They gave it a 3-star rating, but they've been playing around looking at some other plow lights. And specifically, they've been looking at LEDs. They've been looking at what's called an E-code lamp, so there's more on that. This is kind of the overall of what is going on in WSHEMA. Everybody right now is pretty much using a halogen type lamp in different combinations, obviously. And as I said, California at the end here, we're down on this slide, we're using the truck light lamp. So this brought up question in our mind about, are there other lamps out there, better lamps? In the warning light segment, we've transitioned over to LED. LED, it uses less power, probably really great light, but we haven't really transitioned there in snow lights yet. So we started looking at what other lights are available. And one of the conversations that we had, and this actually came from Oregon DOT, was what's called an E-code light. This is a European type light, and what makes it different is that the light is, if you look at the beam shape of the light, they actually start to crop the beam of the light to get it out of the oncoming driver's vision, so the glare of the light doesn't get over to the driver. I want to tell you, though, that the E-code light is not DOT approved, so we kind of stay away from it right now. Okay, so here's some of the other lamps that we've looked at. We looked at a Weldex. It's an LED light. One of the other lights we looked at was a truck light, again an LED light, and I want to think that, I believe this is the light Ohio is using? Yeah. And you'll see this light out there on some of the trucks. So this is an LED light, and it has a heated lens. Another light we looked at is the Meyer Night Saber. This is a halogen lamp. We got this light because it was popular amongst the private sector and plow truck lights on more like pickup plows, what have you. Last light we looked at was Byers Products. This is also under different brand names. Some of you might hear it as Salt Dog lamp. So these are some of the other lamps that we looked at when we looked at the lights. That kind of brought us to what makes a good snowplow light. What are the features you look for that make up a good snowplow light? Well, one of the things you look for is your visibility and how much power you have with the lamp, right? How far can you see down the road? The other thing that we've always looked for is lens temperature. Lens temperature keeps the snow from building up on the lens, and it keeps your light free from the snow, right? Pattern of light, is it a big widespread floodlight pattern, or is it a spotlight type pattern? And the other thing that started to come up, and this is a conversation we had with Oregon, Carl Raschke with Oregon, he brought this up because I had never thought of this before, is the color of the light. Color of the light, and there's thought to be a correlation between light color and snow color. Lights, if you're familiar with what's going on in the LED industry right now, lights, they talk about the color of lights and color temperature degrees Kelvin. So if we go over down the bottom of the scale, this is actually a color temperature chart. On the left side, you'll see that at about 1,000 degrees Kelvin, it's a red color. You go up to about 1,500 degrees, and that's about the color of candlelight. So we move further over the scale, 2600 degrees, it's an incandescent bulb type of light. Going over further, at about 5500 degrees Kelvin, is sunlight, the color of sunlight. We go further to the right, or to the higher degree Kelvin, we start getting into the blues, and if you see 9 to 12,000 degree Kelvin, you're in blue lights. So snow happens to be 5 to 7,000 degrees color. And one other point I want to make, about right in here, about 4,800 degrees is where, and above, is where light, as perceived to the human eye, is intense. So intensity for the human eye starts at about 4,800 and above. If we think about things that we learned in high school science classes, you know, if I said my shirt is red, why is it red? It's because the light bouncing off my shirt or reflecting off my shirt is red. Everything else is pretty much absorbed. Well, the thought with all this is that as we get closer in lamp color to the color of the snow, are we going to create more glare, more reflection from our lights from the snow and from the color of the lamp that we have? So that's the thought about this. Next slide. This is actually a fluid, it's a computer model, fluid model of the front of our plow truck. There's a lot going on in this slide, but it's kind of a neat slide. And basically what happens is, as the snow flows over the top of the plow, this is our plow here, snow flows over the top, we start to create this snow cloud. And when we create a snow cloud here, basically, if I look right over here, that is where we locate our plow lamp, which is about typical where everybody puts their plow lamp, right? So what happens with this is that now our plow lamp has to punch a hole through this snow cloud to have some kind of visibility for our operators. So now, if it makes sense to me that when we look at the beam shape, if I have like a spotlight beam to punch a hole through, I have a small area of light that's going to reflect back to my operator's eyes, as compared to if I have a giant flood lamp out there. If I have a flood lamp, I'm going to illuminate that whole snow cloud, right? So the thought is we have more reflective surface when we do that. So where does that take us from here? We looked at the surveys from WSHEMA. We were looking at, well, how do we start to correlate with what we can measure in the lab to what our operators experience? We bought all these lamps that I just showed you. We bought all of them. And we went out and we did a couple of different types of tests. We did a subjective look at it, and basically this right here is our Snowplow light stand. It is the same height. We set it up the same height as our current plow trucks are. And we took these lights out and we lit them up just to see what the beam shape looked like, see how far you could see down the road with them, you know, get a subjective perspective about what does this light look like. The other thing we did, after we did that, we took them to the lab and we ran through this series of tests with them, from projections, upward projections, downward projections, and I'm going to get into this, lens temperature, and we also looked at color. The colored slides here, these are all the WSHEMA lights that we took out, and I'm going to tell you some standout ones that I thought were standout lights. This is our standard truck light that we've been using for the last 20 years. You know, you look at that light and you look at some of these other lights and you think, wow, it's 20 years old, we probably need to do something different. Wasn't really a standout at all. The Helicombi that Nevada is using, it's a nice looking light. I mean, it was a standout light for me. The next one I say is a standout is this LED truck light that Ohio's using. If I were going to put a light on my car, this is probably the one I'd pick. It's got good visibility, you can see out there. In fact, that's what is in this picture right here. And you can see how bright it is out there. What we did, we just took a kind of look at what does the beam look like, how far can we see out. Lisa was out there that night. We had her all the way out here in this lot, and we were measuring distances off. That was basically a subjective look at the lights. The other one I want to talk about real quick is this Meyer Night Saber light. This was kind of an interesting light because it had a T-shaped pattern to it. So the top of the light was actually cropped off. That was an interesting one. Now we went off to the laboratory. Basically, we tested the lamps against FMVSS 108 standards. We went through and we had a goniometer. Does anybody know what a goniometer is? Nobody? And we want to take a shot at that one? So a goniometer, what does a goniometer measure? It measures gonia, actually, it really does. Gonia is a Greek word for angle, and that's really all this is. 2 months ago, I had no idea what a goniometer was either, so kind of an interesting thing. Anyway, we used a goniometer, and basically we measured the angles of the lights and the intensity of the light as it went through an angle. Let me show you how that worked here. So if we look here, what we started with the light, we had it at 0 degrees. So the face of the light is actually vertical, and then it projected the light forward to a sensor right over here. And then we started rolling the light back. Does that make sense? So really we're looking at the downward part of the light, and we're rolling this back, and we measured that. This is what you get. This is probably where I could have used John's help down here about. But let's look at what it's kind of showing us. This is the Hella light here. So it shows us that at 0 degrees, with that light being vertical, now let me step back here. So the left side is candela per meter squared, which is like an intensity. And the bottom is how many degrees this lamp is being rotated back, okay? This is the Hella lamp. So what this is telling me is that at 0 degrees, this light is facing perfectly forward. It is at its most intense spot. And as I roll it back, it gets less intense as I go down the slide, right, or down the angle. This light here, this is the Aero snow laser that Idaho likes. And if you look at this light, basically what it shows you is that it jumps up quick and falls off quick. So it has a very narrow beam. It's more like a spotlight. So the wider these lights get, the more flood lamp pattern they have to them in the vertical direction this way. Down here, this is the light Caltrans is currently using. And I should tell you, this is the low beam side of it. This is the high beam side. But this is the lamp that Caltrans is using. You can see it doesn't have nearly the power that some of these other lamps have. And some of the other lamps identified within WSHEMA already. Now if I go over to the high beam side, this is the truck light LED light. Just from our subjective testing, I would say, you can see a correlation between what did I see out there just looking at the lamp and how well did it perform in the lab. And that's also the same with this Hella combi. Nevada, I would say there's reasons why they like that light and they gave it a 5-star rating. The other thing we measured, and this is kind of an interesting thing, is we measured the color temperature of the lights. This range right here, this is our color temperature, and this is our angles on the goniometer. This is your 5,000 to 7,000 degrees color temperature of snow. What do you suppose these two lamps are? They're LEDs. LED lamps are pretty much the exact same color as snow. That's kind of an interesting thing. I'm not going to, I have some thoughts about that. I hope it leaves you with a lot of thoughts about that. I would say that, back to my comment, the closer you get to the color of snow, the more reflection you're apt to get off of the snow with that colored light. Look at all the Plow lamps here that WSHEMA is using. WSHEMA is running pretty much all halogen lamps, and they're in this 2,500 to 3,000 color temp. So that's without anybody really knowing anything about the color of snow or LED lights or anything. We all tend it to fall down in here. This is the same slide, it's just on high beam, same thing going on though. The next one we did the same goniometer measurements, but now we did them side to side. And this kind of tells us how wide does that beam go out? Does it go out more like a fog light or is it more like a spotlight? Here's what we got from the test. This is again the Hella combi. It's got a lot of light power. It's got a nice wide beam to it. The next one down is the truck light. You can see, I'll go back down here again. This is our truck light that we're currently using in Caltrans with just our standard 20-year-old truck light lamp. So I think there's a lot of room for improvement in lamps. The last one we looked at with the goniometer was what we started to call glare angle. If you picture this, so this one's a little different, and now I'm rotating the lamp downward, which means I'm actually looking at the upward side of this beam, because that's where, if I go back here, my photometer is up back here now. So in relation to a truck, this is like your headlight, this is the snow or snow bank out here, and this screen that we actually reflected light off of is about 5,500 degrees Kelvin. So it's about the color of snow. So we projected the light, we we reflected it back off the white screen, back to the photometer back here. Very much like a driver driving a vehicle, and here's your driver's eye here looking through the lamp and hitting the snow and coming back. So what we found with this, again, I've got candelas per meter squared on the left, I've got my angles on the right, and everything up in this range here, this 10 candela per meter squared up through 60, it's what is considered unbearable glare discomfort for your eyes. When I get down in this yellow zone here, it is what's considered to be just discomfort for your eyes, but not unbearable. So it's pretty much this area here is you're in a dark room and somebody, sticks a flashlight in your eyes, a very bright light. It's that order of discomfort. Look to see what happens with our lights. If we have our light, when it's aimed and located in this range, and it reflects back to our operators, say we're at 5 degrees, that glare angle is 5 degrees, this is what our operator is going to see. This is kind of interesting because the further we can get from our glare angle down here to 10 degrees, the operator it's more comfortable for the operator. If you think about, the fact that our operator's up here, our plow light's here, and by the time we locate our plow lamp on the truck, how high it is, and then we aim our plow light, the more angle I can get on my lamp, if I can get in that 10-degree zone, it's going to be less glare for our operator just because of the light. Now, if I lower my plow light, I get more of an angle. Does that make sense? This was brought up by a study in Montana State and at the University of Montana, and one of the things they recommended was lowering your plow lamps. Well, this kind of correlates to what's going on in these slides. If you can lower your plow lamp, you get your lamp, if you start changing your degree here to more closer to the 10 degree, and you have less glare back to your operator's eyes. That's the thought. The other thing that kind of comes out of this is you could have a good light, but put it in the wrong spot, and it turns into a bad light, just because of the glare angle on the light. We're out of those slides. You can read a lot into those slides. Lens color temperature. This one's easy to look at. The Helicombi, really hot lamp. Myers Night Saver, really hot lamp. This is back to the lamp we use in Caltrans. It's about 125 degrees. It works. We haven't had a lot of issues with icing over, so we know about this temperature above is good. And again, if I get into my LEDs, I start to fall off, and there could be some concern about icing with an LED light. Here's kind of the 4 lamps that we're looking at running. And I say that because there's some specific things we want to start to look at. The Heli combination C220 that, like I said, Nevada is using, it looks like it's a really good lamp. We're going to run them on our trucks too. We're going to set up a test case with these 4 lamps and run them all to compare them. The LED truck light that Ohio's using, it looks really good, and we want to get more information about how does this light color start to correlate with the color of snow. Is it really that big a deal, or is it not? So we want to get more information on that, so we're going to run that light too. The Night Saber light, I want to step back because I want to show you something with this Night Saber. I forgot to show you. This light here is that Night Saber. Look how flat this is and how low it is in our discomfort level, and then falls off quickly. This is the light that I was telling you had the top part of the lamp was cropped off. And so this starts to make you think about, 20, 30 years ago, we were running Perlux lamps, and they had the louvers in the lamps. It makes you think that maybe if we had a louvered lamp that cropped the top of the light, or like an E-code lamp starts to crop the light, that it'll put us down in this range and we start to have less glare back to the operator. It's another question. So that's why we put this lamp in our list, because there's the thought if we could cut off the top of that projection path, there'll be less glare for the operator. And the last one, our truck light, our old halogen light, we use that as a control model. So those are the 4 lamps we're looking at. So where are we going from here? We're going right back to our operators. We're going to go out and we're going to put these lamps on our 20 of our new Snowplow trucks. Going to put them out in the field, and we're going to let our operators try them and get feedback from the operators. And the thought at the end of the day that we're trying to get to is, what are things that I can measure in the lab objectively and correlate them to what our operators are actually seeing? And what are those things in a plow light that are good features of a plow light that we want? And I think following through on that, if we find out that there is something to color temperature, LED light color is pretty easy to change. So maybe we end up with a lower color temperature and an LED light that's even better than what we have now. So those are some of the thoughts that we're looking at. The last thing I want to say about this is, now we're kind of in the realm of, we've had this realization of where we put our snow lamps and how that glare angle affects what our operators see. We're really starting to look at, where are we locating our snow lamps now? How are we aiming those lights? Where are we locating the lamps so that we don't have as much glare to our operators? And at the end of the day, that's what we're really after, right? Is if you have an operator who can see better, who has less impact on their vision, you have a safer condition for everybody. That's where we're trying to go. Questions? There's a lot here to go over. And, you know, I'm hoping I left everybody with more questions at the end of this than you had when you started. Because when I started going into this, that's how I ended up. It just left me with a lot more questions about snow plow lights and how much or how little I actually knew about them.
Hey Chris, you've heard the expression speed of light, and so speed or light actually has a speed factor to it. Has any of your testing actually taken that into consideration? The speed of the vehicle, how fast it's going, and how far it can reflect at a certain speed?
No. We didn't look at the speed of the vehicle at all.
All this information gathered on your study, was it shared with the vendors that actually produce these lamps?
No, not yet, no. We actually went out and bought the lamps, and then we worked with our own Caltrans lab. And I do know that some lamps you can get some information from the vendor. That, you know, they've done their own testing, and some, you know, not so much. It's hard to get that type of detailed information.
But, you know, are you going to kind of have a meeting with them and say, okay, this is what we discovered, you know, what can you assist, help, or, you know?
Yeah, I think I think where we're at right now is trying to figure this out about what's really going on and if these things really correlate. You know, we can measure it, but, you know, does it really help what we see out on the road? And we may find that, you know, things that we see in the lab the operators aren't really seeing that. It could be that way. I don't know.
I mean, it may not be a big issue.
No, it may not. But we're hoping that some of it starts to correlate, so that if we do find out there's a correlation and that the vendors can change something, then yeah, then we'll be talking to them.
So on that truck light model that you have in your list, you listed one of the concerns as the lamp didn't get hot enough, but doesn't that one come with a heated lamp?
It does, and yes, and even with the heated lens going, that's as hot as we got that light, yeah.
I wanted to kind of piggyback on what Angel asked about sharing it with the vendors. Would you be inclined to share that with like the Virginia Research Council, who also partners with Virginia Tech to do similar research studies? I don't know if the other DOTs have the same type of infrastructure to do that or not, but it'd be interesting to share that with them to maybe not, you know, do the same types of studies that to kind of repeat the process, if you will.
Yeah, I'm not sure that I can say yes to that, but personally, I agree with that, yes. You know, I'm sure we can make something like that happen. I think the more people that have questions and that could help with this process, the better.
I'm a retired MoDOT. I've asked you to recognize that LEDs are monochromatic lights, and that is white light is comprised of all the colors of the rainbow. And what we learned is that when we went from HID white light goes to an amber lens, when you drove the white light so intense, the amber looked white at a half mile away. When we went to LED, it's pure amber color throughout whatever the distance. But an amber warning light on a sign's red, orange, yellow, green, blue, and such, when an amber LED monochromatic light, only that frequency, hits a blue sign and a brown sign, those signs are black. So I would ask you to recognize monochromatics when you're dealing with LEDs.
Good comment. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.